Okay, in this video we'll look at using the Suvat equations, and I will take you step by step through a simple example of how to calculate one of the quantities. So here are the four Suvat equations, just to remind you: V equals U plus AT, S equals U plus V times T over 2, S equals UT plus a half A T squared, and finally V squared equals U squared plus 2AS. Now, let's say we want to solve a problem of this type. If a stone is dropped from rest and falls for 2.0 seconds, how far will it fall? Take G to be 10 meters per second squared and ignore air resistance. So this is a typical sort of Suvat question. Well, the first thing to do really is to figure out what quantities you do know and what quantities you are required to know. So in this instance, we know the initial velocity, because we're told it's falling from rest, is 0 meters per second. We know the acceleration downwards will be 10 meters per second. Let's take downwards as positive to make things easier. And we know the time is 2.0 seconds. And those are the three quantities we know. And the quantity we're asked to find is the distance, how far it will fall, or its displacement, if you prefer. We're not interested in V, okay? We're not given any information about it, and we're not asked to calculate it. So the next thing we need to do is figure out which one of these four Suvat equations are we going to be interested in. Well, we're not going to be interested in the first one here, V equals U plus AT, because it's really for calculating final velocity. We're not interested in the final velocity, so no point worrying about that, and we can just cross that one out. The second one, well, we do want to know the displacement, but we don't know the final velocity, so let's not worry too much about that one. Third one, this one here, is useful to us. We know U, we know A, and we know T, and we want to work out S. So I would suggest the third one would be useful to us. The last one has, once again, a V in it, so we're not interested in that, so let's cross that out. So the one we're interested in using is this third one here, S equals UT plus a half AT squared. Now, we're lucky in this instance, because if I write S equals UT, UT is just 0, so it's 0 plus a half times the acceleration 10 times the time 2.0 squared, and remember we just square the t, giving us a final value for the displacement of how far it will fall of 10 meters. Don't forget units. Two significant figures is enough in this case. Now, had we been asked for another quantity using that same Suvat equation, for example the acceleration, given that it fell for 10 meters, something like that, we would have to rearrange it. Okay, so there may be some algebraic manipulation that needs to occur. In general, the foolproof method for using the Suvat equations is to figure out which four of these quantities we're interested in. Usually a question will give you three and ask you to calculate the fourth, in which case there's always one that you can cross off. In a different example, let's say we are not interested in S. Okay, we're given, say, an initial speed, a final speed, an acceleration. So we're given these three quantities and asked to calculate what the time is. Then the Suvat that combines those four quantities is the first one. Okay, V equals U plus AT. We would rearrange it to make T equals V minus U over A, and then put in the three quantities we want. So that's always going to work for a Suvat equation. The only thing I would say is if they give you S, V, T and A, in that case this one can be modified. You can say S equals Vt minus half AT squared, which is a less common version and simply allows you to do the calculation with the final velocity rather than the initial velocity. But other than that, these 4 Suvats will always be good enough if you have 3 quantities to work out a 4th.